Hello friends, welcome to my YouTube channel. So we are solving mathematical physics question paper of Dibrugarh University uh, of 2022 physics honors. So this is part 2. Part 1 already available in this channel. So link is in the description box, you may go through. And also I have solved the paper of mathematical physics of 2020 I think, and 20 and 21 also. So you can go to the playlist of Dibrugarh University previous year paper solutions, and you can find them. Okay, and I will provide the links also in the description box. So before we start, please subscribe the channel. If you like my videos, please share with your friends and hit the thumbs up button so that you get notified when new video will be uploaded. Okay, so now let's start. So here you can see, so 1 and 2, question number 1 and 2 already we have solved in part 1. So now let's start from question number 3 here. What do you mean by integrating factor? First one, integrating factor, and solve the differential equation. We need to solve this differential equation. First, let me tell you what is integrating factor. It is a factor if you multiply a differential equation both sides, then it becomes integrable. Okay, so let me write the definition. So this is the definition here. Here you see, integrating factor is such a term that if we multiply both sides of a differential equation by it, then the differential equation becomes integrable. Okay, so to make a differential equation integrable, we used to multiply a term on both sides. That term is nothing but integrating factor. So hope you have understood. Now let me go to this equation. So let me write this equation on the next slide. So now this is the given differential equation. If you compare with this equation, equation of this form, before comparing that, let me first divide each and every term by this term. Okay, so this part, x cube minus x. Okay, so if you do so, then you will get. So now you see, in dividing each term of this differential equation by this x cube minus x, we have got this form. So now let us divide the numerator by this denominator, then what you will get. So dividing the numerator by the denominator, we have got x square minus 1. So now the equation becomes of this form. So now from here you see, if you compare this equation with this, if you compare this equation with this dy by dx plus py is equal to q, if you compare with this, then what you will get, then here p will be equal to minus 3x square minus 1 by x cube minus x, and q you're gonna have x square minus 1. That's what you will get, right? So now let's find the integrating factor. Okay, so hope you know how to find the integrating factor. First we need to find the integrating factor. So before that, you know that integrating factor is given by e to the power integration p dx, right? So first let us find this. Let us find this. So integrating factor, this is integrating factor. Now so let me find integration p dx, right? Then this is the p, so that's why you're gonna get minus integration thrice x square minus 1 x cube minus x dx. That's what you're gonna get, right? So now you see that if you take that f of x is equal to x cube minus x, and if you find or if you differentiate it, then what you will get, then f dash of x, that's going to be thrice x square minus 1. So here you see, this is your f dash x, right, and this is your f of x, right? So now you see, this is your f of x. Now we know that integration of f dash x by f of x dx is log of f of x, right? We know that log of f of x. So if you apply that, then what you're gonna get, then your integrating factor will be, so let me go to the next slide. then your integrating factor will be this integrating factor f e to the power minus, so instead of p we have so let me complete the integration first here. So here you see, just let me do a little bit of adjustment here. So then it becomes minus log of here x cube minus x, right, minus log of x cube minus x, since here is the region. Okay, so you have to mention the region here, y. Okay, so this is what we have got. We have got this value of integration, right? So now let us put it here, so that you get the integrating factor. Integrating factor will be here minus log of x cube minus x, and that's gonna be e to the power log of x cube minus x whole to the power minus 1. You can write that like that way, because n log m is log m to the power n, so here we have minus 1, so this is the minus 1 here. So hope you have understood this. So now you see, just wait, let me write it properly, log. So as we have here e, so we can write here x cube minus x whole to the power minus 1, or we can write integrating factor is 1 by x cube minus x. This is the integrating factor. So now what was the differential equation? So this is the differential equation. Let me take this one as 1. So solution of this differential equation, so you can consider this one as the differential equation now. So solution of the equation of this kind of differential equation, in this kind of form. So let me write. Solution of this is given by y is into integrating factor, and that is equal to integration q into again integrating factor dx plus c. This is the solution, right? So our solution will be, therefore, the solution of the given equation will be y into integrating factor is equal to integration q into integrating factor dx plus c. That's going to be our solution. Now y, what is the integrating factor we have got? That is 1 by x cube minus x. That's what we have got. Then integrating factor q is, in this case, what is the q? This is q is x square minus 1 here. So we will write x square minus 1 divided by integrating factor is this, so x cube minus x divided by x cube minus x dx plus c. That's what we have got, right? So now you see, if you take x common from here, then what are you gonna get? So x square minus x, that's gonna be x square minus, sorry, just I made a mistake here, x square minus 1. So taking x common, x square minus 1, we're gonna get, right? So from here we have taken x common, right? So hope you have understood. Now this cancels, so we have integration 1 by x dx plus c now. So that is equal to nothing but log x plus c. So our solution is y by x cube minus x is equal to log of x plus c. So this is our required solution of the given differential equation. So hope you have understood this. Now let's move on to next question, or question number 3. So here you see, now we have to solve this question that solve the following differential equation. This is 3b. So this is the differential equation. So let me write the given differential equation first. So x dx plus y dy is equal to a square x dy minus y dx by x square plus y square. That's what we have. So here, if you simplify this, x square dx plus y dy, and here you will get a square x by x square plus y square dy, then minus y by x square, a square should be there, x square plus y square into dx, right? So now let me write these two terms on one side of the equal sign and these two on the other side of the equal sign. So then what you will get, so then this equation will be, after taking dx common and dy common, that's going to be the simplified form here. So into dy, sorry, not dy, dx. So here is dx, here is dx. If this term is brought to this side, then this minus sign will be plus, right? And dx is taken common. So I hope you have understood this. So similarly, if you shift this one to other side and take dy common, right? So then you will get y minus, just do it, what I have done. Okay. So now just what I have done, I have brought this one also this side, this term also to this side, then I have taken y common. So you can take that y minus a square x square plus y square. So here it's gonna be dy, right? So this is not my equal sign, this is plus, and this is equal to 0. So now this equation is in the form, this is in this form, m dx plus n dy is equal to 0. This is in the form of this type of equation, right? So here you see. So now if you compare these two equations, so then you will get m is equal to this, right? So you're going to get m is equal to x plus a square y, x square plus y square, right? Then let me write it properly. Then you will get n is equal to y minus ax square, sorry, not x square, a square x by x square plus y square. That's what you will get. Now what we're gonna do, we're gonna differentiate m with respect to y partially, right? So that means, so let me write these two on the in the next slide as well. So let me copy this this. So here you see. So now you see, first let me find del m by del y. Then if you differentiate this x with respect to y, that's obviously going to be equal to 0. And if you differentiate this and if you apply the u by v rule, if you differentiate it, then what you should get, b here, v derivative of u minus u derivative of v divided by v square. And if you apply that, then you will get that x square plus y square del y of a square y by then sorry minus a square y, then derivative, partial derivative of, with respect to y, partial derivative of x square plus y square, and divided by x square plus y square whole square. That's what we're going to get. So now if you differentiate it, your result will be a square x square plus y square minus 2a square y x square plus y square whole square. And then if you simplify that, a square x square plus a square y square minus 2a square y square, here we should get y square, right? So then from, sorry, here you will get x square plus y square whole square. So now you see, if you subtract these two, then what you will get, you're gonna get a square x square minus a square y square divided by x square plus y square whole square. Similarly, if you differentiate n with respect to x, right, with respect to x, so then what you will get, so this is the n, right, this is n, right. If you differentiate y with respect to x, obviously that's going to be 0 minus then x square plus y square. Again apply this rule, then derivative partial derivative of a square x with respect to x, then minus a square x partial derivative of this with respect to x square plus y square divided by x square plus y square whole square. That's what we're going to get. So what will be the next result? So this is del m by del y. Let me copy these things. Okay, so now let me go to next slide. So what we have got till now, this is the result we have got. So if you simplify this, then you will have again minus a square x square, then right, then you will get plus a square, sorry, it should be plus, then wait, so then you will get let me write it completely. Okay, twice a square x square divided by x square plus y square whole square, then it will be a square x square minus a square y square divided by x square plus y square whole square. That's what we're gonna get, right? So if you see these two results, if you compare these two results, so we have got these two are equal, right? If these two are equal, then what is the rule that we're gonna follow to solve this? So here you see, just wait. If this condition is satisfied, then we're going to integrate m with respect to x, keeping y constant, right? Keeping y constant. And what is m here? So keep the y constant. What is m here? Here m is this, sorry. So this is the m, right? Sorry, not this one. Here, this is the m, right? So let me copy this thing. This is the m here. So let me post here. So this is dx. Okay. So that's what we're gonna do. So now let me go to the next slide. Let me copy this thing as well. And here you see. So if you integrate this, keeping y as constant, so what you're gonna get y square, x square by 2, integration of x dx, right? Then plus, so here y is constant, so that's why we can write this a square y outside the integral, as y is constant, x is also constant, so we're gonna get x square plus y square dx, right? So you see, if you remember this result, 1 by x square plus a square integration dx, where a is constant. Now in this case y is constant, so here we have a formula that 1 by a tan inverse of x by a plus c, right? So here instead of a we have y, so the a by y, because instead of a we have y now. So now let me continue. So according to that result, that formula, we should get a square y. So here we should get 1 by y tan inverse x by y. That's what we should get. So if you simplify this, then what you will get, this y cancel, right? So our result becomes x square by 2 plus a square tan inverse x by y. That is what we have got. So now, next step is integration of the terms of n terms of n not containing x, not containing x with respect to y. So here, so let me go to the value of n. Here you see, if you see the value of n, there is only one term which doesn't contain x, that is y, right? So we will integrate this term of n not containing x, that is y here. In this case, integration of y dy, that's going to be y square by 2. Now, and the solution of this equation is given by solution of the given differential equation will be given by just let me write here, will be given by m dx where y is constant, where y is constant, plus integration of the terms of capital N not containing y dy is equal to constant. That should be the solution. If that is the case, let us put these values here and let us put it here. So then what you will get, then our solution becomes, first let me write the results of this integration of m dx y keeping constant. So let me go to the next slide. So here you see, so our solution will be in this case x square. So this is the value of this first one. So if you put that, x square by 2 plus a square tan inverse x by y, then plus this result is this one, y square by 2, then we have constant, let it be c. So this is the solution. So hope now let us solve the next question. So here is the next question, question number 3c. So use Lagrange method of undetermined multipliers. Find the minimum value of this subject to the condition x, y, z is equal to a cube. So here you see, so first let me write the function here. So here f, that's equal to x square plus y square plus z square. So this is suppose 1. So now the condition is given that x, y, z a cube. So just make it equation number 2. So now here you see, so taking log on both sides of equation number 2, taking log, we will get log of x, y, z and log a cube, which can be written as, using the property of log, log of x plus log of y plus log of z, right? So here this power should be written before log a. So because we know the properties, log m into n is equal to log of m plus log of n, right? Then log of m to the power n can be written as n log m. So hope you know those properties, right? So now let me clean these things. So here you can see that it can be written as log of x plus log of y plus log of z minus 3 log of a on the other side, that's equal to 0. So now let us take these things, this left hand side part as phi. So here, like phi is equal to, we can write log of x plus log of y plus log of z minus 3 log of a. So what is the idea that what is the method that we're gonna follow here, we're gonna obey here? Let me write here. So if you know f is a function of x, y and z, it is a function of x, y and z, and which are connected by the relation, connected by this relation that phi of x, y, z is equal to 0. That means these three variables are connected by this relation. Then here del f by del x plus pi del phi by del x is equal to 0. Then del f by del y plus lambda, del this is y, del phi by del y, then again del f by del z plus lambda del phi by del z is equal to 0. So solving these three equations, we're gonna get solving above three equations, we will have x, y, z, right? Then we're gonna put the values of, then putting the values of this x, y, z in this equation. Suppose this is in this equation. If you use the value of x, y, z in this equation, this above equation, right? In our case, this is equation number 2 in 2. So then you will get the value of lambda, and then again if you put the value of x, y and z here, you will get the minimum value. So that is the idea here. So now you see, so now let me copy this first two equations and this result also. Here you see, let me paste here. So, and also let me write the phi as well. So this is the phi. Okay, now let us find del f by del x plus lambda del phi by del x is equal to 0. That's going to be equal to, that's going to implies here you see twice x plus lambda by x. Okay, if you differentiate this partially with respect to x, then this derivative of this will be 0. Only one term is left out, log of x, and its derivative is 1 by x. So 1 by x into lambda, that's going to be lambda by x. So here it is equal to 0. So now you see, from here we're going to get x is equal to, our x will be equal to, so because here you see this is twice x square, we will get is equal to minus lambda. We're going to get that there, right? So that's going to implies x is equal to minus lambda by 2 root over it, right? Or you can let us keep it as x square, because we have x square here, right? Just keep it that way. Just wait. Just let me. Okay, so make it okay, make it this way. X is equal to minus lambda by 2. So similarly, if you find del f by del y plus lambda del phi by del x, then is equal to 0, then it's gonna imply that y is equal to root over minus pi by 2. Okay, you can check yourself. So because if you differentiate this with respect to y, then from here you will get 1 by y and remaining terms will be 0. Then if you differentiate this with respect to y partially, then you will get y only, right? Sorry, twice y. And after simplification, you will get this kind of equations in terms of y, then you will get the value of y, right? So similarly you will get del f by del y, sorry, not y, z, plus lambda del phi by del z, and is equal to 0. From this equation you can find that z will be also equal to minus pi by 2, minus lambda pi by 2, sorry, not pi by 2, minus lambda by 2. So I made a mistake here, minus lambda by 2. So now you see, using the values of x comma y comma z in equation number 2. So then what you will get, so x, y and z, let us put those values here, right? Put these three values here. So then you will get that minus pi by root over minus lambda pi by minus lambda by 2, so into root over minus lambda by 2 into root over minus lambda by 2, that's going to be equal to a cube, right? So which means minus lambda by 2 whole cube is equal to a cube, right? So which means a is equal to root over minus lambda by 2. So hope you have understood that this is the value of a, right? So what will be a squared then? Okay, what will be the value of a square? So why should I take a square? Because you see, wait. So instead of squaring both sides, here you can notice that one thing. So we have x is equal to root over minus lambda by 2, right? So value of x will be, therefore value of x will be equal to a. Similarly, y is also have the same value, so you can write that you can see that z is also same value, have the same value, x, y equal to z is equal to a, right? You can write a because a is equal to minus pi by lambda by minus lambda by 2 root over minus lambda by 2, and which is equal to x, which is equal to y, and which is equal to z, right? So value of all those terms is nothing but minus lambda by 2, right? So now if you see, as we have finally got that x is equal to y is equal to z is equal to a. Now if you put those values here, right, if you put those values here, I have replaced this term by a, right? So if you put those values, putting the values, these values in 1, if you put the using these values in equation number 1, we will get that now f will be equal to, so now you see that we have got a is equal to root over minus lambda by 2, which is equal to x, so x can be written as a. So similarly y also is equal to a and z is also equal to a. So from 1 we will get a cube, sorry not cube, x, a square plus a square plus a square. So this is the minimum value of f. So there are 3a squares, so we're gonna get f is equal to 3a square, right? 3a square. So this is the minimum value of f, that what we needed to find, right? So hope you have understood this. So now let's move on to next question. So here is the next question. Find unit outward normal drawn to the surface of paraboloid of revolution this is the equation of the paraboloid at the point this. So first let me write the given equation. Okay, let me write the equation of the paraboloid, that is z is equal to x square plus y square. So this can be written this way, x square plus y square minus z is equal to 0. So now let us take phi is a function of x, y, z, that is x square plus y square minus z, right? So let me consider that way. Then the normal vector is given by del phi, right? Del phi, so that is gradient of phi. So here del y del x I cap z cap, then del z k cap, right? then phi is here x square plus y square plus, sorry, not plus, minus z square, sorry, minus z, not z square. So this is the phi. So this is going to be if you differentiate x square with respect to x partially, then that's going to be twice x, and if you divide this partially with respect to y, then you have to consider x and z constant, and twice y. Then if you differentiate it with respect to z partially, then you're gonna get minus 1, right? Minus 1, k cap is there, so here I cap, here z cap, minus k cap. So at the point, normal vector at the point, what is the point? This is the point 1, 2, 5. At that point, so normal vector at this point is given by, so now replace this x by 1 and replace this y by 2. Then as z is not present there, so this vector becomes 2I cap. Then here, if you put y is equal to 2 here, 2 to the 4, z cap minus k cap. So this is the normal vector. Now let's find the normal unit vector. So normal unit vector. So first, the unit vector, how to find a unit vector, you have to divide this vector by its magnitude. That's how we used to get normal unit vector, right? Therefore, unit outward normal vector is equal to here 2I cap plus 4z cap minus k cap divided by its magnitude will be given by 2 square plus 4 square plus minus 1 whole square. That's what we're gonna get, right? So then if you evaluate it, then what you will get, 2I cap plus 4z cap minus k cap, and under root 2 square 4, 4 square 16 plus 4 20, then minus 1 square is plus 1, then 20 plus 1 21, root 21. That's what we're gonna get. So this is our normal unit vector, right? So hope you have understood this. Now let's move on to the next question. So our next question is write the probability distribution function for binomial and Poisson distribution. So then we have a problem that we need to solve here. So first let me write the probability distribution function for binomial. So that is, so this is the probability distribution function for binomial, and I have written the meaning of P and Q here. I have used, and Q is equal to 1 minus P, the probability not happening, probability of not happening A, and here P is the probability of happening A, right, in one trial. So here this this we used to find the probability of happening of an event r times probability of an event happening r times in n trials, n number of trials in r times, right? So hope you have understood this. So now let's go to the next part. Now let me write the probability distribution function for Poisson distribution. Okay, let me go to the next slide. I will write the, here you see, now probability distribution function for Poisson distribution. It is nothing but a particular limiting form of binomial distribution when here you see, when the P and Q, here P and Q are very small and n is very large, then the Poisson distribution is given by here is the Poisson distribution is P of R is equal to m to the power r e to the power minus m divided by r factorial, and here m is the mean of the distribution. M is the mean of the distribution. Right. So now let me show you how to solve the numerical part. Okay. So 3 distinguishable balls are distributed in 3 cells. Find the conditional probability that all the 3 occupy the same cell when at least 2 of them are in the same cell. Okay. Now here you see we have 3 balls and 3 cells, right? 3 cells, right? So this can be filled by any one of this, if there is no restriction, there is no condition, then we can fill these 3 cells with 3 balls by 3 into 3 into 3 ways, right? So we can write 3 cells, the 3 cells can be filled with the 3 balls in 3 into 3 into 3 ways. That means 27 ways, right? So hope you have understood this, right? Now let us consider that A is an event. All the balls in the same cell, right? So then probability of A, so it can happen 3 out of 27 times, right? And because you see 3 balls in the same cell, so it may be in this cell, it may be in this cell, or it may be in this cell, right? So 3 out of 27 ways. So now that's going to be equal to 1 by 9 after cancellation. And suppose P means the events at least 2 balls in the same cell, right? 2 balls in the same cell, then probability of B, that will be given by 1 minus, that is the total probability, that obviously 1, probability of the sum of the probabilities of all elementary events is 1. So here I have written 1. So here we have to, in order to get at least 2 balls in the same cell, in order to get its probability, we have to subtract all balls in different cell, right? So if we subtract the probability of all balls in different cells, then we will get the probability at least 2 balls in the same cell, because, and the probability of the 3 balls in the same cell is also included here, because when 3 balls are in the same cell, so it fulfills the condition that at least 2 balls in the same cell, right? So we can say that A is a subset of B, right? We can say A is a subset of B. So that is why A is a subset of B. So that is why we can write probability of A intersection B, that's going to be equal to probability of A. Now we need conditional probability. So here the conditional probability A by B, so that is given by probability of A intersection B by probability of B, that's going to be equal to probability of A intersection B, as A is the subset of B, so here we can write probability of A by probability of B. And we have got so here I forgot to complete these things. Probability of B, that's going to be 1 minus all balls in different cells, and that's going to be you know, factorial 3 by 27, right? Factorial 3 by 27, because we can fill the cells with the 3 balls, right, in factorial 3 ways. That means here you see first ball, if you first ball fill the first ball, if you want to fill the first cell, sorry, not first ball, then you have 3 balls. Out of any one, out of 3 you can put any one of them. Then once it is filled, then only 2 balls will be left out. Then for the first one you have 3 options, for the next one you have 2 options, for the last one you have 1 option. So that's why 3 2 into 1, that is factorial 3, and these 3 cells can be fulfilled total 3 3 3, that means 3 into 3 into 3 ways, right? That means 27 times 7 total number of ways those 3 cells can be fulfilled, that is 27 ways. So that's why we have got this factorial 3 by 27, and that is equal to, so here 1 minus, sorry, let me go to here 3 to the 6, 6 1 the 6, so 6 by 27, so that's going to be equal to, if you cancel this to 6 2 3 3 9 the 27, then 9 minus 2 by 9, and that's going to be equal to 7 by 9, right? 7 by 9. So here we have probability of A is 1 by 9 and probability of B is 7 by 9, and in that case 9 9 gone, we have 1 by 7. This is the answer. So this is the answer, and this is the required conditional probability. So hope you have understood. Now let's move on to the next. So before we solve the next question, let me tell you that I am in Dibrugarh, Siring Sapori. So if you want offline classes, if you are a student of BSc Physics, if you are in Dibrugarh, then you can take offline classes on classical mechanics, mathematical physics, quantum mechanics. And if you are a student of class 11 and 12, you can take physics offline classes with me. And to join offline class, send me an email here. This is my ID, ozanlekhisit123@gmail.com. So now let's continue. This is 3f. Here we need to evaluate this, and where f is equal to this vector, f is equal to here, let me write here, f is equal to x square I cap plus xy z cap, and c is the boundary of a square, in the plane z equal to 0, that means xy plane. So this is the coordinate system, x, this is y, this is z. If z is equal to 0, then xy will be the plane, right? So hope you know these things. So bounded by the line x is equal to 0, x is equal to a, then y is equal to 0, and y is equal to a. Then let me draw the xy plane here. This is y, this is x, and this is simply z. Suppose this is the z, this is x, this is y, right? So x is equal to 0, that means this is the equation of y-axis, right? This is x is equal to 0. Then x is equal to a, it is a line parallel to y-axis. this is suppose this length is suppose a, so then this is x is equal to a, this line is x is equal to a, then y is equal to 0 means the x-axis, y is equal to 0 is the equation of x-axis, then y is equal to a, suppose this is a, then this is the line y is equal to a, y is equal to a, then this is the square bounded by c, right? C so c is the boundary of this square, right? So c is the boundary of this square, right? So hope you have understood this. Now how to evaluate closed integral f dot dr, right? So how to evaluate this? So we're gonna use the Stokes theorem. So let me go to the next slide. First let me okay, just wait, let me use this part. So now you see integration f dot dr, so surface integral curl of f del cross f, right? Dot n cap is the unit vector ds, right? This is Stokes theorem. This is Stokes theorem. So hope you know the Stokes theorem. Right? So here n cap, that will be the unit vector which is perpendicular to this square, that obviously along z axis, so we can say it is k cap, right? We can say here n cap is nothing but k cap, right? So that's why first let me evaluate this del cross f. Okay, so del cross f, so del cross f, curl of f means, so here I cap, z cap, k cap, then del x, del y, and del z, right? And x square, xy, here we don't have the z component, so here it will be 0. And if you evaluate this, if you expand it, then what you will get, for I cap 0, derivative of 0, that's going to be again 0, and derivative of xy with respect to z, that's going to be again 0. So that's why we will get 0 into I cap. Similarly, minus z cap into what we're going to get for z cap, derivative of 0 with respect to x, again 0, then derivative of x square with respect to z, then again it is 0, so 0 minus 0, 0 minus 0 means 0, 0 z cap, then plus, then for k cap, what we can do, that derivative of xy with respect to x, that's gonna be y only, partial derivative, right? Y, then derivative of x square with respect to y, that's gonna be 0, so y minus 0 k cap, that's what we got, right? So now let me copy these things, just wait, let me copy these things and let me paste in the next slide. So this is the next slide, and let me also copy the boundaries. So these are the boundaries, right? These are the boundaries, these are the boundaries, right? And let me copy the diagram as well. So this is the diagram. Right, so that is what we have got. So that's going to be equal to y k cap, right? Y k cap. Okay, so now you see, we can replace this del cross f by y k cap, right? Y k cap, and this n cap can be also this is a normal unit vector, this is normal to this surface, and this square that we have taken, bounded by the boundary C actually. And as here you see, this surface, this square is on xy plane, So that's why its normal unit vector should be along z-axis. So that's why it says we can take this as k. So now we can write that integration f dr, that will be equal to surface integral s. So curl of f, we have got y k cap. Then again n is this n cap is replaced by k cap, because normal unit vector is along z cap, right? So then ds here, ds can be written as x dx dy, right? So dx dy, because here you see this square is on xy plane. So if you consider here length, if you consider very small unit area on this xy plane, very small unit area element on this square of dx dy length and breadth, then we can replace this dx by dy, right? So now you see what we can do here. K cap, that's going to be 1, right? K cap, that's going to be 1. So then we can write integration dx. So x should be integrated from 0 to a, right? 0 to a. So this is 0 to a. Then again we have y dy, that should be also integrated from 0 to y, right? 0 to y is equal to a. That means 0 to a, right? So if you integrate this, then what you're gonna get? So integrating dx, we have got x. So 0 to a. Then if you integrate y, then you're gonna get y square by 2. So from 0 to a again. So if you put the limits, then you should get a into a square by 2, which is equal to a cube by 2, right? So this is the required answer. So hope you have understood this. So we have completed question number 3. Then in the next part we're gonna solve the questions of question number 4, and then this paper will be completed. And thank you for watching. Stay connected. If you are new to my channel, please subscribe the channel. If you are new to my channel, please subscribe the channel and share with your friends. If you think these videos are helpful, hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Okay, so see you in the next video.